Hello, I'm Defne, and this is my report for Physics 101 laboratory project. The main objective of my experiment was to calculate the percentage of energy loss during the conversion from spring potential energy to kinetic energy. Theoretically, the kinetic energy should be equal to the potential energy, but in the real world, we know that isn't true. So my goal was to determine exactly how much energy is lost when we change variables like spring coefficient and mass. To do this, I used 3 different springs and 3 different masses with the same surface area. After finding the spring coefficient of each spring by vertically hanging a 200 gram mass from them, I moved on to the main procedure of my experiment, which was to compress the springs, launch the objects, and measure the projectile distance. But while doing so, I encountered a major problem. The table surface was just too long and the springs were not strong enough to actually make the objects reach the edge of the table. To fix this, I improvised and used a really heavy jar as a backstop, and I attached the springs to it, and then that allowed me to shorten the launch distance, and the objects would reach the edge of the table and then to the ground. After these adjustments were made, I found the potential energy in each trial by using the spring coefficient we found previously and measuring the compress amount. After launching the objects, I measured how far they landed from the edge of the table and then calculated the kinetic energy right when the object was on the edge of the table. Here are the percentage of energy loss for the 9 trials I did. First, if we take one mass and change the spring, the data showed that our stiffest spring was the most efficient, losing only about 24% of its energy. In contrast, the weakest spring struggled the most against friction, losing nearly 47% of its energy. This suggests that a stiffer spring transfers energy much more efficiently than a weaker one. On the other hand, if we take one spring and change the mass, as I increased the mass of the object from 16 grams to 61 grams, the energy loss increased dramatically. You can see here that for the heaviest object, the energy loss reached nearly 80%. This confirms that the kinetic friction force, which depends on the normal force, is the primary cause of energy dissipation. In conclusion, while we successfully achieved the objective of calculating the energy loss, the values were higher than we initially predicted. The primary source of error was clearly the sliding friction on the table. However, we must also consider that the springs themselves have mass. Some potential energy was absorbed to accelerate the spring's own coils, which was not transferred to the object. Despite these real-world factors, we have successfully demonstrated the direct relationship between spring stiffness, mass, and efficiency. Thank you for listening.